Just one more minute and we'll get started here, folks. Perfect timing. I just finished up my latte. Okay, let's get started. I'm Jim Quancy, Senior Director of Software Partner Development. I know several of you on the line today, though I surely don't know all of you. Thanks for joining us. This session should take about an hour. It'll somewhat depend on how the Q&A goes. Do note you can use the chat or the Q&A capabilities of Zoom. I've got two folks, Sandeep and Ziru, kind of scanning the chat and the Q&A area. So if you have questions, they may jump in during the presentation and ask me to expand on something depending on what you're asking. Do note that we are recording this session. It will end up in YouTube on a few days. So if you miss something, don't be nervous. You can get back to it, or if you want to refer today's webinar to a friend because of something you heard during the event, absolutely do that. That's why we're doing this, to get the word out. Our theme for today, Autodesk DevDays 2020, is very much the desktop and the cloud together. This is the exact same theme we had a year ago when we did DevDays, and I suspect we're going to be doing this a while, because reality is our customers are big users of desktops. Desktops are great tools and the right tools for creation and editing of a lot of design and engineering data because of the nature of that data and the performance requirements that our customers have. But at the same time, design and engineering and construction, fabrication, manufacturing is a team sport. And when it comes to working in teams and, large teams of stakeholders, which can go from service people, customers, subcontractors, kind of whoever, the cloud is the best way to collaborate. And I think there's no question about that. So those two working together, desktop and cloud, are an important part of what we do, and I think of what many of you do. And let's get into our content. Do recognize during this presentation, I will be talking about some things that are happening in the future. Nothing I say is actually a commitment to deliver anything in the future. But we do believe as partners, you should be aware of what we are working on, what we hope to do, what we intend to do. But again, no promises. This is a really a legal requirement and a financial accounting requirement that we make that clear. And as we go through this, at times I'll say some things that are pretty solid, and there'll be some other things that are a little bit more uncertain. But I think we believe we need to equip you with the information you need to make your investment decisions, whether that's money or time or people or marketing, kind of whatever. This presentation and all Dev Days taking place over the next week and a half is about giving you that information you need to make good business decisions. So again, our agenda for Dev Days, you can see it here. I won't read it out, taking place over the coming week or so. we're going to work our way through the flagship Autodesk desktops, as well as our cloud, our web services, Forge, BIM 360, Fusion, and the Sword. I thought I'd start out with a little bit of financial information, because there was a 2-year period there where Autodesk was going through this transition from perpetual software to subscription, losing money, revenue going down. Financially, it didn't look good, though this was expected. There is a cash flow valley you kind of go through when you make this transition from perpetual to subscription. But we're at the other side. This income statement evolution is just, I took it straight off the web. You can see where we are today. I will say, you see that 2020, that's an estimate. Autodesk has not made its financial declarations end of year, which is actually coming up in the next few days, actually later this week. We'll be presenting to the financial community exactly where we ended up in 2020. But here's what the financial community was planning based on what we've told them in briefings. And you can see Autodesk revenue, sales over $3 billion, operating profit approaching $1 billion. A big thing the financial community looks at is cash flow. We're looking at cash flow of well over $1 billion. And so it's never been higher. Autodesk revenue, profits, cash flow are at record highs. And as you can see, the financial community expects them, and we expect that to continue to grow quite dramatically. And if you look at it, if you look at it over a period of 5 years, Autodesk over doubling our revenue and kind of infinite growth in profits and cash flow from the money-losing valley we went through during the transition from perpetual to subscription. Now, what's this mean to you? This means Autodesk is growing. So you're investing in Autodesk technology. It's good, it's safe investments. We have the money, the profits we need to fund advancements in both our desktop and our cloud technologies, as well as significant acquisitions on the cloud side of the business to grow that. So, and the number of users, and I think that's my next slide, continues to grow dramatically. Slide after this one. That growth, it's across all sectors. You can see AEC, 36% growth, manufacturing, 15% growth. AutoCAD, people go, well, is that slowing down? 29% growth year over year. M&E, which had been flat for several years, up 19%. So we're seeing really good growth. And you can see the growth by, on the right there, by geography, Americas, Europe, Asia. I mean, it's up, up, and up everywhere. And it's funny, you could sit there and go, well, the weak man's manufacturing up 15%. Well, that's probably double our nearest competitor. So let's just say business is good. I think when you invest in Autodesk platform technologies, whether it's desktop or cloud, you're making a good investment because Autodesk is investing, and you're in a position to leverage those investments. Now, something I used to do historically was talk about the number of subscribers, and we would actually report this information out to the financial community. Though we stopped doing that, and that has to do with we've made a number of acquisitions, things like Assemble, PlanGrid, Building Connected, and those are different kinds of subscriptions. So when you start to count users, the actual subscribers has grown dramatically in this last year based on these acquisitions. So we actually stopped publishing out the number of subscribers. But these are customers who are using our products, getting value, paying us every year for that value they get. So again, I think working with Autodesk is a safe investment. And if you're looking to grow your customer base, your user base, working with us is a good way to do that, and taking advantage of the fact that we can reach all these customers, and you can work with us to reach them too. Yeah. So we're going to jump in. We're going to walk quickly through a number of the desktops. This is going to be short, 1 or 2 kind of PowerPoint slides per desktop, because later in the week, we'll have full 45-minute hour talks about what's happening with the platform aspects, with the APIs of the various desktops. So AutoCAD 2021, that's coming up this spring, codename Rogue. A familiar diagram for those of you who work with AutoCAD. DWG is not changing, right? So for the fourth year in a row, no change in DWG. Now, binary compatibility, we are having a binary compatibility breaks. So after 2 straight years of not breaking binary compatibility, so for those of you working with Object ARX, you'll need to do a recompile this spring to support Rogue, AutoCAD 2021. And Visual Studio, we're moving to the latest version of Visual Studio with Rogue, and that's part of the binary compatibility break. Moving to the latest Microsoft toolset, Visual Studio 2019. Okay, and this is just another way of looking at it for those of you who are actually coding, things like your installers. When you're looking at the API major version, you can see we're bumping to version 24 with ACDB. And again, you can see Visual Studio and .NET Framework moving from 4.7 to 4.8. And again, if you tune in later in the week, you can kind of see the kind of full detailed presentation on what's happening with the AutoCAD platform. And if you have AutoCAD apps, a bit more detail on what you need to do to stay compatible with the latest release. Revit, also moving to .NET 4.8. Here's a list. There's a big, long list of Revit API changes. We have a big API team that works on Revit, lots going on. Again, I'm not going to go through all of this, but really encourage you to sit in on the Revit API webinar taking place later in the week. You will see a lot having to do with performance. I mean, customers continue to push for larger and larger models. You'll also see level of detail. People want to drive fabrication, prefabrication more and more from the BIM. And so we just continue to add more and more information. Analytical information too, because BIM is very much about the eye and being able to do simulation and analysis. So enhancements continue to be made, onward and upward with Revit. Inventor, little comparison here, last year to this year. Last year, we actually had a little bit of a breather. We've actually grown the Inventor API team more recently, increased investment there, and you can see it with new functions, versus last year, 40 new functions on existing objects. This year, we have 71 functions. Last year, we had 10 new objects. This year, we have 15 new objects. So, investments being made and actually increased in Inventor. And a lot of that driven by what you're asking for and what customers are asking for. So I do encourage those of you, whether it's Revit or Inventor or AutoCAD, don't be bashful asking. We have engineering teams committed to these desktops and moving them forward and making them more capable. And no, I'll be talking a lot about Forge later and, our marketing. We talk about the cloud a lot. You shouldn't view that as some kind of disinvestment or decreased investment in the desktops, because, we all get when it comes to the creation and the editing of CAD data, desktop tools are the right answer. Okay, so just some other tidbits on what's new in the Inventor 2020 API, 2021 API improvements, part document API improvements, drawing documents, assembly documents, general API improvements. Again, making the point, we continue to invest and we're actually increasing investments in the Inventor API. And I was talking to our product manager just a few weeks back, and he's absolutely encouraging me, saying, hey, bring me partner customer needs for the Inventor API. Fusion 360, some changes there. Now, we had this Spider IDE kind of built into Fusion, and we've replaced that with Visual Studio Code. Now, some of you may go, what's Visual Studio Code? right? So Visual Studio Code, build and debug modern web and cloud applications. Free and available on your favorite platform. Linux, Mac, Windows. It's open source base. It's integrated with GitHub, right? Now, it's not the same thing as Visual Studio. And I've got it here somewhere. Yeah, here we go. So write code.visualstudio.com, code editing redefined. I'll tell you, my team has been building widgets, plugins for Visual Studio Code. For those of you who haven't touched Visual Studio Code, I really encourage you to give it a look. What else? Fusion 360, new methods and properties. I think the big one is adding your own toolbar tab, and you can see these new methods for working with toolbars. So you can make your add-in a more integral part of the Fusion 360 user experience. Max and Maya. Now, Maya has gone kind of off cycle. Though most Autodesk desktops, the major new releases happen in the spring. Maya actually had their major release just 2-3 months ago. So they're not on that same spring cycle that the rest of our products are. It was a binary breaking release. You might want to check out the blog. There's been a few oopsies and fixes that took place since that release a few months ago. 3ds Max 2021 is on that normal spring release schedule with the rest of our desktops. And Max 2021 is a binary compatible release. And again, you can, I encourage you to go to the beta forums and check out what's going on in detail. And always refer back to the blogs where we always put out the latest kind of breaking information as new releases come out and as we get questions or issues come up. Okay, so that's the quickie on the desktops. Now I'm going to move on to the Forge roadmap. For those of you who've seen the Forge roadmap video from the Forge DevCons, this is going to be very familiar. There have been a few changes, and I'm going to point those out kind of as we go. So again, Forge, our cloud-based platform that is used across virtually all Autodesk, frankly, both desktop and cloud-based products. Again, just a reminder, we've been talking about things about the future, and I say this again because some of what I'm going to be talking about on the Forge roadmap side is a bit more in the future than some of what I've just talked about on the desktop side. So I think it's important to recognize what I've said before is there's no promise, but we feel pretty good about and we're well along with. Some of what I'm going to talk about next is a little, some of it's a bit less certain, and we'll get into that. So again, for those of you not familiar with Forge, what is it that customers are building with Forge? What partners are building with Forge? Data viz, digital twins. I probably hear a new digital twin application from a partner every week. There was 2 earlier this week. There was 1 the week before. A lot going on. AR, VR pipelines, SaaS integration, like with whether it's Maximo or Primavera, P6, or whether it's SAP or Oracle or Microsoft Dynamics or Azure or kind of SharePoint, OneDrive, Dropbox, kind of whatever. Catalogs, spare parts catalogs, configurators and design automation using the new design automation engines, in AutoCAD, Inventor, Revit, and Max all up in the cloud. And in a minute, we'll talk about a 5th engine. And last, photo to 3D, turning photos into meshes. So today, these are the primary Forge APIs: data management, moving files around, design automation, again, those engines I just talked about. Model derivative API, taking 2D and 3D drawings of models and extracting information, whether it's to view or whether it's to actually get at the data, whether that's a JSON string or what's in effect SQLite. Again, reality capture, photo to mesh, BIM 360 API. And, we say API, it's really APIs. There's probably 8 BIM 360 APIs, depending on different APIs for the different BIM 360 modules, with more coming. And then webhooks for notifications. So future looking, I want to let you know we're working on this. We've been talking about it for about 2 years now. But I have an expectation by late this year, by our Forge DevCons at the end of the year, we'll have details here. And there may be a few of you on the line now who would like to get involved a little earlier, kind of as alpha sites. So just be aware we're working on this. A collection of platform components that supports common data management, data modeling, and eventing needs of Autodesk and third-party apps, right? It's about, yes, working with files, which we all live with today, but also working with data. It's about empowering you, customers, partners, to be able to work with design and engineering data, either at the file level or at the, I'll call it the object level. Today, we're mostly limited to dealing with file level and having to get object data out of files. And what we're working on in Forge Data is to make it so you have a choice. Whether you want to get data from out of a file, which takes time and has compute costs, or whether some subset of that object data in a file is already in a proper database where you can run a query and very inexpensively and quickly get data. Counting, scheduling, costing, materials, energy analysis, other kind of structural simulation, kind of whatever that may be. And clearly when you're in a collaborative environment, that ability to easily see changes in object data can be powerful stuff. Okay, so moving from proof of concepts to building a performant, scalable, and resilient architecture and system, I will impress on you, we've been working on this for 2-3 years. I'll tell you, last year we ran into some real challenges on performance and scalability that had us do a little bit of going back to the drawing board. I know we have a few customers and partners that are a little disappointed that it's taking us longer than we had hoped, but our point of view is better we learn the limitations so you don't have to. So as we expose it to you, we've already made sure it will deliver the performance and scalability, the resiliency, the reliability that you want and expect. I call it us taking the arrows for you. But I ask you to be patient, hang in there. We're on the road, and we'll have more to talk about later in the year on this. And again, anyone who is aggressive and also has some pretty good deep expertise on working with CAD data, and again, whether that's BIM or manufacturing based, and sees the value of having easy access to more granular data, object level data, we'd love to chat with you about potentially working as alpha or beta sites, kind of maybe mid this year, later in the year. So as we get to the end of the year and we talk to a wider range of people, we've got some examples of what some of you have done. Okay, so focusing on data interoperability and granularity, advanced permissioning, search, and other capabilities that support collaborative workflows, advanced querying, insights, and machine learning AI on the horizon. Because I think we all know things like machine learning and AI, artificial intelligence, doesn't work unless you have easy access to granular data. So Forge Data is really setting the stage to giving us all access to the easy access to the data we need to be able to deliver all our customers, all our users, a smarter, easier, more insightful, powerful experience. Okay, viewer. Now, this is about improvements on the viewer that's already happened over this last year. Improved microstation support, improved 2D PDF support, dramatically increased performance. And for those of you who don't know it, we've also just recently added direct PDF viewing, where you don't have to use Forge Model Derivative to make PDF viewable. The Forge viewer will view PDFs directly. And we've just recently updated the API documentation to make it easier for you to work with. Something that people have been asked for some time was being able to work with rooms and spaces with Revit. Rooms and spaces were always available in 2D view, but as rooms and spaces in Revit don't really have a volume, a mass, they weren't accessible in a 3D view. At the same time, some of you know that Navisworks had a way of kind of transforming kind of a 2D, kind of a closed polyline rooms and spaces into a 3D space. And we've been hearing from many of you for years that you wanted the same. So we've added this new request parameter, generate master views to model derivative, and it will turn rooms and spaces into proper volumes. So you can view it in 3D in the viewer. We're not done here. I've got the same request from people to do the same thing for viewing IFC files. Yes, more work to do. What else are we doing with the viewer? Faster loading and higher performance viewing of very large models. When I say very large, gigabyte, multi-gigabyte size, and models with lots and lots of entities, like you can see here, rebar. That is coming, and it looks like April. If you were at the DevCons, you heard about this October, November, December. I was hoping we'd have that out by now. But it's going to be April. You can expect to see this enhanced performance for very, very large models. Improvements in IFC coverage, that's an ongoing thing. As you use IFC and the viewer, if and when you find gaps, do let us know. IFC is a bit of an evolving format that we're constantly chasing, and frankly, it's your requests that really drive what we do. Point clouds. Now, we have code samples that have shown many of you how to add point cloud capability to the viewer. Do know we do expect to add some basic point cloud capability to the viewer to support what our desktops can do with point clouds at some point in the future, like this year, I hope. If you're already doing point clouds with the viewer, there's no reason to slow down or stop, because we're going to basically, our target is to replicate what the desktops do. And I know many of you working with point clouds with the viewer are going way beyond what we do with the desktops. So I think there's plenty of opportunity there to add value. We're also doing foundation work to support emerging industry viz standards, MaterialX, USD, something Apple's pushing hard, GLTF. If you're attuned, aware of GLTF, do know we have a little bit of a skunkworks project where Forge Model Derivative will crank out GLTF files. It's a bit of a kind of pre-beta alpha stage, but if you want to test it out, reach out to us, let us know, and we'll hook you up and you can help us kind of debug that. The intention, though we don't have a date, would be to make GLTF a standard output of model derivative. So you'd have a choice. You'd have SVF as you know it today, OTG, which is effective for very large models, GLTF, which has, to some degree, better visualization and is a bit lighter weight, though you also lose some kind of capabilities on the data side. But we do want to recognize, depending on the problem you're trying to solve, the visualization requirements you have, you may want to use, you'll want a choice of these outputs to use, and that the viewer will support. And with that, I'm just going to run a little video here that shows a very large model. And this is care of one of our partners, Norconsult. Norconsult's design and engineering firm, a construction firm, and also a system integrator who does work for partners and customers. We've been working very closely with them over 2 years now on dealing with very large models. In this case, that's rebar, reinforcing steel and concrete. You kind of look at it and go, is that rebar? Oh yeah, that's rebar. You'll see here as we get farther in, there's hundreds of thousands of pieces of rebar in this model. And that wouldn't be unusual in a large project with a lot of reinforced concrete. And this used to not load at all. And now it loads relatively quickly. It loads on mobile devices which frankly is one of the main use cases for being able to view rebar, because you want to do it out in the field as you're, putting together this rat's nest of rebar and trying to understand, what rebar goes where. So pretty cool stuff. And again, I want to thank Norconsult for kind of working with us on getting this right. And again, I mentioned earlier, it's probably going to be April-ish when you'll see this kind of capability pop out. BIM 360 APIs, there's a lot going on there. I'm just going to point out a few things. Some of this an update from what we talked about at the DevCon. So on the project user API, we have a lot of people that want to automatically create projects, query projects for users. The project users API is probably the most widely requested API we have. Disappointing to say we still haven't released it. We do expect it to happen in the next month or two. We are really, really close. I ask for your patience. We're getting there. What else to point out? Folder permissions, model coordination, cost management, public beta, formal release. We're kind of right on the edge for some of this stuff. Some of the things, if you've never seen Project Home with partner panels, I suggest you to do a Google search, BIM 360 partner panels. It's the ability for you to take your applications and put them inside the BIM 360 interface so the users can have a very integrated experience. And what we frequently hear from customers, they'd like their users to be able to go one place, BIM 360, and gain access to all their tools, whether those tools are from Autodesk or from you, and whether you is a customer with a custom app or an ISV with a commercial app, you can absolutely expose those within BIM 360. It's in effect an iframe embed inside BIM 360's Project Home partner panels. SaaS integration, I thought I would show off the cost API so you can see, it's not just talk, it's real. And this is working with Sigma Est, who's one of our partners, does cost estimating. They're based out of, I want to get this right, Belgium. They do business both in Europe and the US. And this video here is going to show their desktop app, again, which many of you have, with the ability to reach into BIM 360 to find a project, to find a model, to then get all the object level data to pass to the desktop app to do cost estimating, and then to pass that object level data back into the new cost module inside BIM 360. So here, importing a BIM 360 model into Sigma Est. Here's the BIM 360 model structure. And you can imagine Sigma Est does queries, links up the object data from inside the BIM with cost data. And within the cost estimating system, anything that might have been missed, you can manually make links. And you can see this detailed cost estimate information. And again, it's kind of seamless, versus, extract a file, export a file, import a file, match it up, and then 2 weeks later have to do it again. In this case, being able to do cost estimates basically in minutes, or I shouldn't say that, it may be an hour or two to kind of fully flesh out the cost estimate the first time, but then updates become minutes. And here we are in the BIM 360 cost management module with that same cost information, so that the project manager, the project team members can track, how is the cost going against what was budgeted? Is this going to be a profitable business or not? Now we're going to look at BIM model coordination. And this is a proof of concept. This is a code sample available to you that reaches into model coordination. And when I say model coordination, think like Navisworks. We're talking clash analysis. Does this look like Navisworks, where we've got models in a column, models in a row? here's the clashes between two different models. There's 719 of them. The actual model will come up. And I know some of you are probably interested in an example of Power BI integration using a building information model, using Forge, using data from BIM 360. This is a great code sample for that. So here we have a single web page, Power BI, BIM, model coordination, clash information, visual model to provide context on specific clashes, analytics on clashes so you can see who a supplier may be, or where are the most problems coming so you can learn over time. And so the whole project team can see what's going on, and can recognize problems ahead of time. So when you have those weekly, bi-weekly coordination meetings, most of the kind of day-to-day conflicts are already settled, and you can really focus the meeting on the hard, gnarly bits where somebody's going to have to make a significant change. Here you can see we did an extract of all the clash information into an Excel spreadsheet. And I think we're just about done here. This is a very cool, and again, you'll find the up on GitHub, you'll find this code sample. Don't you love this? BIM 360 issues and modification of the viewer to show bullets or hotspots or sprites, depending on what you call them. And BIM 360 issues all connected. Okay, let me keep moving here. I thought I'd show a VR example integrated into BIM 360. We have probably a dozen partners, customers who've done integrations using Forge with their favorite VR. Notice we are inside BIM 360 here. This is the BIM 360 viewer. Notice the view in VR button. And what's happening here is the kind of the tour guide is starting the tour in a specific part of the model and then invites everyone else to join them for that walkthrough or for that look at clashes to get a feel for what's going on. And from within this VR experience that Insight is built, we're going to be able to do redline markups, create issues, push those issues straight back into BIM 360 where the whole project team can see what happened. Pretty slick creating issues with voice to text, because anybody who's done VR knows trying to type in VR is a bit of a kind of a clunky experience, to say the least. Okay, we'll keep moving along here. Okay, design automation APIs, version 3 came out at the end of October. So Revit, Inventor, Max, AutoCAD, they're all out there now. Headless CAD engines, visualization engines up on the cloud. And what is coming? We actually have an internal alpha of Civil 3D as a CAD engine on the cloud. And I'll show you a bit more. I'll show you 2 code samples of that we've built out to help our engineering team get Civil 3D right. First, what would you use these CAD engines for? Here we'll run a video from CADcraft. And the interesting part with this web page configuration of a balcony is it creating a Revit family? Is it creating an Inventor assembly? It could be doing both. And we have a number of examples now of customers, of partners building apps that do both, because they're helping building product manufacturers serve their customers better, deliver their customers an online design experience that dramatically reduces and simplifies and delights the whole sales kind of specification process. Right here, drawings, we have examples of cranking out, emailing PDF files, after the experience. And you'll see here in a sec that in this case, what it's actually creating is an inventor model. So all ready for fabrication. Or for, additional detailing as may be needed for the actual fabrication of this balcony. Okay, let me keep moving here. Another very cool video and very different and a complex web experience. And taking this here right now as Inventor, it's taking an Inventor app, I think it was iLogic based, and actually moving it to the web. You may be sitting here going, what is this? This is a drainage system that would typically sit under a parking lot. When parking lots get built, there's all this water runoff. What are you going to do with it? The company who had this website built by one of our partners, ImagineIt, did this to allow their customers to specify these drainage systems on the web. Now, this is typically a very technical customer, a civil engineer who wants to get this drainage system designed and then get a quote and get the specifications for permitting all on the web. You like this? This is a PDF file being used as a backdrop and it being scaled so that the design work can be done right over the PDF. And I'm sure some of you are thinking, I've got this problem. I have to start with these kind of dumb PDF files and I have to turn them into intelligent CAD information. And that's what's happening right here. And I'll let this run. Again, pretty complex interface. You can define fittings and sizes, and you can see volumes and system lengths and analytical type of information. As this user, again, someone like a civil engineer is designing this drainage system from a web page. And at the end of the day, it's going to crank out an inventor model. So Advanced Drainage Systems, who's the manufacturer, can go straight into fabrication, reducing a sales experience that used to take weeks down to less than a day, and dramatically reducing mistakes because the customer, the user, has been more deeply involved in the design, and the design doesn't have to go through 2 or 3 different hands. And the more hands that touch it, the more likely there's going to be a mistake. Here's the drawings. Drawings that are important for permitting. This kind of drainage system, parking lot design needs to get local building permits, and they want to see, how you're handling the drain runoff. Creates drawings, actually emails, PDF files right back to the user, to the customer, so they can review it. And again, get the permitting started. Very frequently, permitting is the limiting factor for these kinds of projects. Okay, another interesting example of design automation using Inventor in the background. Now you may be sitting here going, "What's going on?" This is a raised platform. This is ImagineIt again, who kind of built this for one of their customers. And you'll see here when you see it what got designed, and there it is. So a very simple. That was an SVG-based interface that was used for the specification, and then using Inventor on the cloud to actually do the design work to create the assembly. And here it is, open an Inventor ready for additional detailing as needed, or maybe creation of assembly instructions and the sort. Design automation systems, one of our partners who builds these kind of automation systems for a living. And here, I'll let this run. And it's interesting, they've built 2 apps that basically do the same thing. One does it with Inventor, one does it with Revit. Again, an example of where you may have applications for building product manufacturers where they want to hand the architect or the building engineer a Revit family or a Revit model to use. And at the same time, they want to create an Inventor fabrication model so we can go straight into the factory, minimize mistakes. So here's basically the exact same design being done, only this time cranking out a Revit model. And this is going to take a sec. Again, Design Automation Systems has done a number of these kinds of projects. Pretty powerful stuff, and pretty powerful stuff for our customers, your customers, who are able to deliver a quick, delightful experience to their customers, and dramatically reducing sales times, dramatically reducing times from customer inquiry to it hits the shop floor to it actually ships and then arrives on site. Now, I thought I'd show something just really simple, because I hear all the time with people, they just want to go through some Revit parameters and they want to check them maybe against standards and they want to update them. And maybe they're updating them with phase information, maybe they're updating them with R values, maybe they're updating with serial numbers, whatever that may be. This proof of concept was hacked together from one of our other proof of concepts by one of our sales engineers, Yves Verlert, based in Europe. Again, this is an example. You know, you can go up on GitHub and see it. And it's very simple. Looks for specific parameters. You can see here fire ratings, door instances, exports them to Excel, where there you can then make changes to Excel and then bring them right back into the Revit model. He uses a spreadsheet, but no, instead of a spreadsheet, it could be anything. Again, maybe it's P6, Primavera, maybe it's Maximum, it's operations and maintenance, maybe it's costing, you know, counting, purchasing, kind of whatever. Here, he's putting the fire rating and comments information into the spreadsheet, and then he's going to push that information straight back into Revit, using Revit up on the cloud. Very simple, but you know, sometimes the simplest code samples are where you start. Relatively straightforward. And I know many of you are data hounds, and once you know how to do this, and many of you use Excel for prototyping, once you get your hands on this, it becomes quite straightforward to do the same thing with whatever your external data repositories, sources kind of happen to be. And I think we're going to look in here straight into the, using the model viewer, straight into the doors where you can see these new parameter settings that have been updated. Fire rating information. Again, fire rating information. Okay, we'll keep moving. Bleeding edge, something done by Jaime on my team. This is a web page. It's got a grid. It does a little bit of snappy kind of stuff. He just drew a wall and a floor plate, and he passed it to Revit, and Revit passed it back. And now he's putting furniture in, information which can be saved, passed back to Revit, update the Revit model. Now, I want to be careful here. This is not about turning Revit into a web environment. There's no constraints here. There's no dimensioning. Building a real kind of CAD engine on the web is hard stuff, as we've spent a lot of time sorting through with AutoCAD Web. But we do want to let you know there are use cases like sales use cases or kind of simple configuration use cases where that ability to build a model kind of on the fly may be something you want to do, and something that is very much possible with these CAD engines on the cloud. Something from Atkins, just to show you, this is Revit and Max together, and it's a very cool example. Now, this was an Autodesk University 2019 class, so you can go watch this hour-long class. Just do a Google search, Autodesk University, Forge, Atkins, and you should be able to find this. Look for Mustafa when you do the search, and you'll find it. Okay, what's happening here, it's loading the model in the Forge viewer. You can then modify your camera location to get the view you want. All right, so you can typical Forge viewer navigation, find the view you want, and then hit the button and send that model and that viewpoint to 3ds Max for photorealistic rendering for ray tracing. And that's what's happening right here. And in a sec here, we will get that photoreal rendered model back from Max. And you gotta love this interface. My hands off to the Atkins team. This slide bar experience to show, again, that's a 3D model on the left, as would be showed by the Forge viewer from Revit. And that's a photoreal rendering using IES accurate lighting on the right. And this is work Atkins had done for a retail customer. Okay, and my little teaser before, which was about Civil 3D on the cloud. I'll run 2 quick examples of what Augusto on my team has been building. Now this is straightforward. We've seen this looking at Civil 3D information through the viewer, but that style information, that's new. You were not able to get style information, you know, out of normal kind of Forge model derivative. And by using Civil 3D up on the cloud, which is not released yet, and we're probably several months away from it being released. But again, if you have interest, and here I'll show you another example of Civil 3D as an engine on the cloud. If you have interest in maybe being an alpha site for this, Augusto is looking for people to work with who have some real problems they'd like to solve by taking advantage of Civil 3D, you know, up on the cloud. Now, what's happening here? Export to land XML. So using Civil 3D on the cloud to take Civil 3D projects, create land XML files to push them out to project team members who may not have access to Civil 3D. Maybe they're working with, oh God forbid, MicroStation or, you know, some other technology, which customers do. We all live in heterogeneous environments. And or maybe it's someone you don't trust with the source DWG, but you're happy to give them a land XML file. Okay, so interested in being an alpha site, augusto.concalves@autodesk.com. Let him know, but do let him know if you're serious. You got a real problem that you think Civil 3 on the cloud as an engine could really help you with. Okay, now this wasn't working this morning, but you know, let's go find out if my friends have gotten this working. There we go, we're up. I thought I'd take the time to show this because it's more along this infrastructure area. This is the Forge viewer working with 20 kilometers of roadway. Again, a special thanks to North Consult to lending us a roadway model that we could show. We wanted to show an example of operations and maintenance, you know, otherwise known as digital twins these days, of a piece of road with a nice, cool user interface where you can move along the road by station markers, by kilometer or mile markers, depending on, you know, who you are and where you're from. Now, this is big. I don't know if I recommend people do 20 kilometer chunks. Maybe 5 kilometer chunks would be good enough. And you could tell the data is still loading here and it's going to take a minute, but I'm going to give it a chance to load because the fact that this works at all kind of shocked me, getting my hands off to Augusto. We're also doing some things to actually increase the capability. We do have customers asking about working with 200 kilometer pieces of road, which is a bit much to say the least. Am I going to be patient here? This is taking a bit. You know what, while I let that load, I thought I'd show another example one of our partners had done in the traffic area. This was done by one of our partners, CC Tech, that's actually using machine learning to look at video. And this is a single video camera looking at traffic, and it's using machine learning to identify cars. But on the left here, now this is a live website. I am navigating around the live model using the Forge viewer. And because this is in the Forge viewer, this is real data. Where this video isn't data, there's a real data feed. Each car, where it is, where it moved to and from. So the ability to use video and machine learning to get data that can be analyzed and that can be presented in context is pretty slick. And how are we doing here? I'm going to try poking around here. We'll see how we do here, even though this model hasn't fully loaded yet. Yeah, so I went to the 1 kilometer mark. You know, let me go to try to go to the 2 kilometer mark. Yep, here we go. 2 kilometer. Now there's yellow here at the 3 kilometer mark, so I don't know what that's about. Let's go find out. There's been a report of some potholes at the 3 kilometer mark. And let's be clear, this is a 3D model. I can, rotate it, zoom in. Let's go to the 5 kilometer mark where there's a camera. And, oh, my camera's down today. This was a live camera feed. Not with me today. Let's go to the 6 kilometer mark, see what's there. 7 kilometer mark. Hey, here we're bringing up a drawing, so some real civil engineering information, and we'll chunk along here. 8 kilometer, 9 kilometers, 10, 11. Oh, and there's a little red mark here at 12. We'll see what that's about. So there's been some, you see this red hillside? There's been some kind of cave-in at this spot. So pretty cool, to say the least, the fact that you can do these things with what's a big honking piece of road. Pretty slick, to say the least. Okay, let me keep going. While I was doing this digital twin thing, for those of you who kind of haven't seen the latest, I thought I'd show a little more. Here's a machine, jet engine, vibrations. Maybe we want to real-time data. Maybe we want to see issues, or maybe we don't want to see issues. There's too many. Maybe we want to see maintenance information on a specific area, unlike that turbine. Maybe we want to see procurement information, again, on a specific part. And we'll see if this starts up. This is kind of the same thing, digital twin, only this is, in this case, it's a process plant kind of experience. And a quite different kind of interface. Or a plant where I can, let's take the piping out and the structural out and the electrical out, and we'll just leave the vessels, and we'll go to real time, and I can select a vessel, and here's real time data, and maybe I want to look at issues of a specific type, or maybe I've got Google Maps here. Maybe I want to go look at a totally different facility. Oh, that's the facility I was already at. I should have gone to the other facility. Anyway, hopefully inspiring you on what you can do with a web page. Okay, let's go back to my PowerPoint, and we are running out of time. Okay, so Forge, what did we look at for what's coming, what's happened in some cases? Design Automation API, right? It was just AutoCAD a year ago. Now it's AutoCAD, Revit, Inventor, Max, and sometime later this year, Civil 3D should pop up. Model Derivative API and Viewer, being able to deal with PDFs at higher velocity, improvements in MicroStation, but maybe the biggest thing is dealing with very, very large models. This edition, in addition to SVF, OTG, experiments we're doing around things like GLTF, Material X, USD. And again, lot of improvements in the BIM 360 API, which I really encourage you to attend the BIM 360 API webinar taking place. Is it later in the week or early next week? And then long term, where did I start? Talking about Forge data. So just keep that in mind. Again, reminders. Hopefully you'll join us for more of these webinars. Again, if you miss any, they will all end up on YouTube by the time we're done. It's generally a 2 or 3 day lag between the time we present and the time they show up in YouTube. And I encourage you to kind of share this information with the people you work with. And now we're to Q&A. And I haven't heard anybody chatting.
Hi, Jim. Sandeep here. There are a couple of questions in the chat window.
You bet, Sandeep, but I'm looking at the Q&A one just for now. Is it possible to retrieve models in the project files folder with the model coordination API? Well, to grab projects in, when you say the files folder, I assume you're meaning BIM 360 docs, and that you generally use the data management API. Now, I may not fully appreciate what you're asking. So I suggest you sit in on the BIM 360 API, or if you go to forge.help at autodesk.com, it'll say that again, forge.help at autodesk.com, you could ask that question directly, and one of our engineers will respond. So the code sample on GitHub for Power BI, can you provide a link? So I am gonna be really dangerous. And what I encourage everybody to do is Autodesk, Forge, GitHub, Power BI, and I know Zhao Dong did that. And we'll see what we come up with. Autodesk, Forge, BIM 360, Clash, Power BI, right at the top. I lucked out. So let me Control C that, and I will put that straight back into our session. And chat and answer live. Oh, that's not what I had in mind. A type answer. Oh, it's gone already. People are too fast for me. Maybe hopefully you've caught that, and or somebody's answered it already. I'm gonna type the answer right here. Control V so people can find it. There we go. Send. Okay. Who to contact to possibly be an alpha developer. So if you're referring to Forge Data or to Civil 3D as a design automation engine, you can always use forge.help at autodesk.com. That works every time. Whether it's to be an alpha site, whether you have a specific question that occurs to you later, or maybe when you're referring back to this webinar, or friends referring back to the webinar on YouTube, and you want to go, I have a question, who do I ask? Okay, questions? Sandeep, anything else?
There is one more question from Go. Can I learn the meaning of using state API?
So Sandeep, we cannot hear you. You're extremely garbled, so I'm going to suggest you stop trying to talk.
Can I learn it?
No, Sandeep, please mute yourself. Yeah, that's better. I think probably the best approach for me to do is to, I'm gonna guess some of this is in chat. Yeah, there's 8 chat questions. So I'm gonna go look through the chat questions myself. And hopefully everybody's gonna have patience with me. Does Jim know his camera is on? Absolutely. Code samples, there we go, we did that. Can I learn the meaning of using 3-stage and 2-stage? Thank you. I think you mean, this has to do with authentication. Is it 3-step or 2-step? That is a very general kind of web term, and I hate to tell you this, I'm going to do this again. I'm going to go 3-legged and 2-legged OAuth, and we'll say OAuth too, because that's a general web thing. A typical OAuth workflow involves difference between OAuth 2-legged and 3-legged. We're right in Stack Overflow. So, this is less an Autodesk thing and more a web thing. So I suggest you just Google it. Now there are clearly some Forge APIs only support 2-legged, some only support 3-legged, some support both. If there's a specific Forge API you have questions about 2-legged, 3-legged, again, forge.help@autodesk.com will get you there. Or again, a Google search on Autodesk Forge, you may find the answer in our Forge blog, or already answered up in Stack Overflow. And another detailed question, how to secure your Forge apps on AWS using Parameter Store. I don't know, again, forge.help@autodesk.com. Okay, in what countries are Autodesk servers available? So we have data centers in the US and the EU. And when I say the EU, it's actually an AWS data center in Ireland. We actually have 2 in the US, and that gives us failover capability, and the 1 in the EU. We are doing work looking to expand the number of data centers, but that's kind of a late this year conversation. We'll kind of see how that goes. No formal commitment for additional data centers yet. I tell you, we get requests for data centers all the time, but we can't, it's more than we can ever do. I mean, people want them in, Russia, Brazil, China, Australia, Germany, France. It's a bit overwhelming. Every data center we pop up costs us millions of dollars to run. Now, if you have customers that have strict data sovereignty requirements, I do suggest you reach out to us and we talk about what you can do. What I call where your data at rest is always in your country region that you're restricted to. You may have to pass the data through Forge in a transient way, but it never stops. And for a lot of customers, that's kind of good enough, knowing that there's an approach to this, that their data is never stored in the US or the EU or, wherever it happens to be that your customer cares about. Okay, I already answered alpha developer, just forge.help@autodesk.com. We'll get you a response. And let me go to Q&A. We got anything else going on? I notice ArcGIS has created an experienced developer. Any chance Forge may be going that way? I don't know what that means. I think we're going to have to do some research. And I'm going to suggest, Alice, again, send an email to forge.help@autodesk.com. So once one of our folks does a little research on experienced developer, or maybe somebody like Augusto on my team is a GIS kind of guy, he may know the answer already. He can get back to you directly. Alice is giving me the exact website. Anyway, any other questions while I, create your first web experience. You know what? I have an answer for you. Learn forge.autodesk.io. Yes. This is where you want to go. And it walks you through it before you start coding. Tools, OAuth, this is that 2-legged, 3-legged thing. Basic model viewing. How to reach into BIM 360 in Fusion. Modifying models using design automation. Viewer extensions. The viewer is based on WebGL at the bottom, and then there's a middle layer of 3JS. So there's quite a bit you can do in terms of viewer extensions. dashboarding, deployment, support. It's all here, and this is step by step. So, for example, why don't I reach in, view your models, and you can see here, this tutorial will guide you through a web app. It gives you all the basics, creating a server, authenticating, everything you need to do. It gives you choices, depending on what you want to work with on the server side, PHP, Go, .NET, Node. So hopefully that helps. Okay, any more questions here? Let me scroll down, there may be more. Perfect. Good we could be of help, Alice. And that does make me think, again, for anyone, forge.autodesk.com. But, I tend to not go here. I tend to just Google search. Community, blogs, system integrators, documentation, where lots and lots of information like, data management, model derivative, introduction, developers guides, lots and lots of information here. Let me go to model derivative just for fun. Developers guide, step-by-step tutorials. There's a lot of information here. Though as my 20-something-year-old sons tell me they don't like this kind of way of learning, they go Autodesk, Forge, let's say viewer, and let's say YouTube. My youngest son, he's a YouTube guy. He always goes there first. Right? Lots and lots of YouTube information. Lots to see. In fact, I just did a whole YouTube series. Autodesk Forge, what is it? Introduction to Autodesk Forge. Actually, I just did a new one. It doesn't show. Oh, here it is. Introduction to Forge in a 7-part video series. And it works through visualization and analysis, digital twins, AR, VR, SaaS integration, parts catalogs, configuration, and automation. Okay, we are 10 minutes over. Any questions left? Oh, here we go. Is there any comparison on the cost between creating a design using design automation versus development in a desktop app? When you say cost, I'm not too sure what you mean, because if you have a desktop app that you have a plugin running an automation, I mean, your cost is your, what's it going to cost to run on your desktop or on your server? And, I don't know what that cost is. I will say when you run apps on design automation for Revit on the cloud, it runs faster than it runs on your desktop, because we've removed all the user interface. And how much faster? It kind of depends on what you're doing. But I have seen, twice as fast, 20% faster, 30% faster. So if waiting for a process to finish is a problem, you may find design automation helps. Now, do note, forge.autodesk.com, you can see all the cost information. It is a bit of a longer conversation because you pay for a compute hour, and what's a compute hour? And a lot of people, I tell people, build your app on a desktop, put in some monitoring on what the compute time is to run your app on the desktop, and real compute time, not user time. And then recognize that it'll run a bit faster on the cloud, and then you can look at the cost. And for those of you not familiar with it, running Revit, Inventor, or Max on the cloud is 6 cloud credits per compute hour, which is nominally around $6 compute hour. Now that varies by country you're in. It's lower cost in some countries. And depending on who you are, you may get Autodesk cloud credits at a discount. If you buy a lot of cloud credits at one time, you get a discount. So, to some degree, you should go try. Oh, and AutoCAD on the cloud is 4 cloud credits per compute hour. And a lot of computes don't take much time, 10 seconds, 20 seconds, 30 seconds. So a compute hour can be a lot, depending on what you're doing. Though I have seen some relatively complex computes with Inventor and Revit that take, 5-10 minutes. Somebody looking for a sample including Power BI and Forge two-legged OAuth. So Francesca, I'm going to recommend you forge.help@autodesk.com so we can get back to you with a specific link, or assuming we have such a thing. The other thing is, when you ask for this kind of thing, if we don't have it, the answer may be we can make it for you. I mean, that's one of the reasons we're here, to build code samples. Could you repeat the Civil 3D alpha request email? And I will go back to here. And let me do full screen. And augusto.concalves@autodesk.com or forge.help@autodesk.com. Either one will get you there. Any roadmaps about getting Revit model usage data? I think a longer conversation, probably worthy of a conference call and a screen share. Clearly with Autodesk Model Derivative, with Forge Model Derivative, and with Forge Design Automation for Revit, you can get that kind of information. But this will quickly become cost, performance, because in both cases, it kind of takes real kind of compute time to get it done. And how often do you want to do it? Is it something you want to do, by the minute, by the hour, by the day, once a week? So we should have a longer discussion about that. Okay. Great. I think we're good there on questions and answers. And anything more on chat? And I think I answered that. Anybody else? Going once, going twice. I could see we're number of participants is starting to work its way down. So what I am going to do is just remind people we've got more to come. I hope you join us. Again, this session is recorded and will be up on YouTube in the next few days, as is true of all these sessions. And I thank you, all of you who asked questions. Love having an engaged audience. We're here to help. As I tell partners all the time, don't be bashful. Software developers tend to be bashful and tend to thrash a bit before they ask for help. We are here to help. I have a team of 30 engineers, and their job, they get paid to help you. So, please take advantage of it. And with that, have a great day.